Thank you.
Yes, ma'am. Thank you so much, ma'am. That was, that was much for me, but I'm not that at that level. I'm still learning from you, and
No, we all
yes,
are
ma'am.
learning,
Yes,
Samir.
ma'am.
I'm also learning. Yeah, I also don't know. I mean, so many things you know better than me. I know.
With that.
So we all are
And
learning.
yes, ma'am. Thank you so much for giving this opportunity. So we'll start this session today um, with some content that will be based on the classification and regression problems based on where we will utilize support vector machines. So I'll first put off my video because I have to share, and it will, you know, it will use that bandwidth. So limited bandwidth is there. So I'm stopping my video right now. Yeah. So I think I am audible enough. Let me share my screen. Yeah.
Yes, you are audible, Samir.
Yes, ma'am. Thank you so much, ma'am. So I'll request everyone who is doing because it is a hands-on session. So I'll request everyone to open a new browser window at your end, and please open the drive folder that is already shared with you. So in that drive folder, let me tell you where is that drive folder. So in this drive folder that is already shared with you, there is a folder named as Day3 lab session. So in this Day3 lab session, I have shared a CSV file that is a data file that will be we will be using to train the SVM for different tasks. So I'll request everyone to get prepared with this thing, that you have to download this CSV file. So first you have to right click on that and download this CSV file in your desktop or laptop. And then when you'll open this, so I'm saving this file. Okay. And when you will open your drive, so open your drive, make a new folder at your drive. Like this is my drive. So please make a new folder. Rename it as AI&ML Asia Connect Day 3. So I've renamed it as AI&ML Asia Connect Day 3. Do this, and yeah. So do this, and then there will be a new folder at your end. So Asia. Yeah. So this Day 3 folder is my own folder, and I have to the downloaded file, I have to upload it in this folder that I have created in my directory. So it is that I'm asking you to make a new folder in your directory. So at your end and in your directory. So I think meanwhile, when I'll be telling you these things, I'll ask you certain things like please reply me, please acknowledge me whether you have done or not. So in the chat, if you have done this thing, you have uploaded a new CSV file in your Google Drive. So please write uploaded in the chat so that what is not received. Okay. So Neha ma'am, can you please help Khushbu madam? Please add Khushbu ma'am to that folder, or let me do one thing. I'll attach this file. Let me attach this file if it is possible for me. Okay. So I can, yeah, I can do that. Yeah, good. So yeah, okay. So Neha madam will do that, and I'm
So
again.
please, I'm already writing. Please, when we give you access, when we give access to everyone, then you people start, writing about material. So please wait. Already Purnima has shared you the link of a drive where you can get the CSV file for the lab today. Remaining all lectures which are streamed through YouTube, we are just uploading a Word file to give you link. Okay. So please wait. Everybody, please don't drop message for the content. See the link shared by Purnima. I'm repeating it again.
Okay, so Trupti ma'am asked me. So what you have to do is a Google Drive folder is already shared with you all by the project team, and then where you will find a folder that is named as Day3, like Day3 lab session, this Day3 lab session. Inside Day3 lab session, there is a file that is a CSV file that contains the data that we will be using today to train the SVM classifier and regressor. Okay, so you need to download this file first, and then you have to make a new folder in your directory, in your Google Drive, and please upload this file to that Google directories. So likewise, I have done this. I've created a new folder AI/ML Asia Connect Day3 in my Google Drive. This is my drive. In this drive, I have created a new folder, and then in that folder, like Asia, this is the folder that I have made, this AI/ML Asia Connect Day3. So this is my folder that I've created in my machine, in my Google Drive, sorry. So in that Google Drive, I've uploaded the same file that is uploaded in this Asia Connect project folder. So this is what I have uploaded at my end.
Chat पे ध्यान दे रही हो ना? अच्छा, ठीक है.
Ma'am, your mic is on, I think. Yes, ma'am. Okay. So okay. So this is done. I think this is done at your end. Now, what is this? Where this data I get? So you have to open, like, first Google and then search for UCI repository. UCI repository. UCI repository. So UCI machine learning repository is there. That is a repository created by. Let me close this thing. Yeah. So one. Yeah. Okay. So this is the repository that is created by University of California, and then here there is a link. Click here to try our new website. So please click on that. That is a new interface that they have given. That is easy to read. So in this directory, there are ample data sets that you can use for classification and regression type of problems. Okay. So this is the repository that you can use from your side, and in many research papers, these data sets have been used and they have been cited. So I'll request everyone to search for this data set that I've given you, that is Algerian forest fires. Okay, so Algerian forest fires data set. So this is the data set that I've taken from this repository, and when you will click on this Algerian forest fires data set, okay, so this is the data set. Here you will get the information about this data set. So there are 244 instances, but there are two regions. Like Algeria is in Algeria there are two regions. Béjaïa is the first region, and Sidi Bel Abbès is the second region. So they have taken the data from these two regions, and they have separated these two data. When you'll download this CSV file from here, like download, so you'll find the CSV file, and there will be two separate things, like one data belonging to Bijaya and the second one from CD. So I have only taken the first one, that is Bejaya region. And because the data was, this is the session that I should tell you how to use like these repositories. So we have taken only one region. Second thing is that what is inside the data. So when you'll open this CSV file, you can see that there is there are attributes. Okay, so from A to N, there are attributes, and the attributes have the day number, month, year, temperature. So these values, these attributes are separated into two classes. So let me tell you those two classes. So these two classes are weather data observations and FWI components. FWI is fire weather index components. Okay, so FWI is fire weather index. So when you'll open this thing, you'll find these things. So one more thing is that there is an on which year it has been taken. Day, month is already there. So these are the values that are very critical. And one more thing is classes. So reading these values, you can they have identified whether there was fire or not. So no fire was there. Not fire is the label. So what is label? Label is what this data tells you about. So the label is not fire. This is not fire, and this is fire. So this is a two class classification problem that is given. Okay. So what we will do, we will take this data set, we will take these values attributes, and using these attributes, so these are the attributes for training the classifier. Okay, so we will be using 122, I think 124. Okay, so there are we'll remove this thing. Yeah, so here you can see that there is one column that is classes. So it will be considered as the label. Label means what should be like, what is the outcome from these attributes. So what a classifier should tell you about. Okay, so this is the data set that we have downloaded earlier that was containing two things. So but we have to take only the first part. Okay, so how we have taken that first part. So I've removed the lower part from there, and we have prepared that data set. So directly removing from here. Okay, so I've removed that thing. Yeah, this is what is removed. Okay, so only these much things are there from day to classes. Now let's come back to the drive. Yeah, so here is the drive AI/ML. This is the I think, yeah, so this is the file that is shared with you, because the sharing sign is there. Now here when you have uploaded, just see that the date. Okay, so this you have to remove. Okay, so what you have to do, I've already told you that you have to remove the first line that was there inside this data set. So that I have removed, and the lower region that was that we have not to consider. So this is the data set. So first I will save this thing. So this is what .csv. Now I'll upload this CSV. Yeah, so here. Okay, so I'll remove this one, and because I have changed this thing, so I'll remove the updated one. I will insert the updated one into this folder. So you can do this on your side, and please in the chat write to me like updated. So this is the updated file. So in the chat, please write updated, what I've asked you to do. Okay. Yeah, thank you so much. So I think you have this updated file. Again, I'm telling you, in this updated file. Yeah, So there is the first line is the column name, and there are no other data set. So there are how many lines? One from 1 to 123. So how many lines for data? So only 122 lines are there for data. So we will call them as rows. So these are rows and these are attributes. So from A to N, these are attributes. Okay. Now let us open here at your end, at your folder, right click on that folder there where you have pasted your, so I'm going here. I'm closing this thing so that there is no confusion. So here, this is my drive, this is my file, and then I'm pressing right click, I'm doing right click, and then I'll open a new collaboratory over here. So Google Collaboratory. So more, and then collaboratory, this Google Collaboratory. So this collaboratory will help you to write codes in Python, Keras, and in the upcoming sessions where we will be using Keras for, making deep learning models and for making neural networks. Right now, today we will be using sklearn library. So this sklearn library we will be using today, scikit-learn, for SVM as a classifier. So there are, this is the library that is giving you classification, repository, this library, regression library and clustering library. So we will be using classification as well as regression. Yeah. Tomorrow, Atif will be there who will be delivering the clustering. Okay. So come back to this thing where you have created a new notebooks. This is untitled notebook. So we will rename it as AI/ML AC for Asia Connect, and then SVM, and then classification, CLASS. So this is the first thing that you have to do at your end. So please write in the chat collab if you have done this thing, collab. Please write in the chat if you have opened this collaboratory notebook. Okay. Yeah, so many acknowledgements I can see. Thank you so much. So we'll try to, first thing that should come to your mind is how to handle the data set. So to handle the data set, we can use pandas. So pandas is the library for working with some data sets, and it has certain functions for analyzing the data, for cleaning. There is a, because data can be, if we want to clean that data, because there can be entries which are not sufficient to train for these entries to give to the classifier, so that classifier can be trained. So there are many operations that these pandas will give you, and using this pandas we can do much, to pre-process our data, and then we can do the classification or regression kind of thing. So first thing is import pandas as PD. So this is the first thing that you have to write, and in this cell you have to write import pandas and PD as PD, and then you have to click on this play button, so it will run the code. So why it is taking time? Because when you have created this notebook, there was no machine that was connected with this notebook. So this is a cloud platform. Okay, collaboratory is a cloud platform where you can have a virtual machine connected to this notebook right now. So here you can see that when I ran this cell, here there is a machine that is allocated by Google, And here you can see that there is some amount of RAM space and disk space that you have been given. So this can be different. RAM can be same, but disk space can be different for different people. So don't worry about that, because it depends on from where your mail ID you have got. So the administrator have given you how much space at in your directory. So import pandas as PD is the first thing that you have to do. There are more libraries that we will be using, like import numpy as np. So numpy is very important thing. If we have to plot some figures, so import matplotlib dot pyplot as plt. So these are the libraries that we will be using. Okay. Now, so we have to read this CSV file. So this CSV file is actually in the Google Drive. This is the drive. In this Google Drive, this file is located. Okay. And this is a different machine that we are using right now. So this machine has its own space. So this is the space this machine have. But we need to take the data from the Google Drive. For that, you have to mount the Google Drive, your Google Drive. So for mounting that Google Drive, you have to press on Mount Drive button. This sign is there where you will find a Google Drive option. So you can click on that. It will ask you, yeah, whether you want to permit access to the Google Drive. Yes, I want to give, I will give the permission. And then it will mount the Google Drive. Yeah, it is saying mounting Google Drive. And it is saying this may take too long. Okay. So when the Google Drive is mounted, you will see a drive folder over here, drive folder. So I'll click on that. In this drive folder, there are two things, shared drives and my drive. So because I have created this folder, AI/ML Asia Connect Day3, this is my folder. Okay. So what I have done, I've created this folder in Google Drive. So I will go inside this Google Drive and locate that folder. So this is the very first folder that I am having. Yeah. So there are two things. This is Algerian forest fires and AI/ML AC SVM classification. These two files are already there here. So I will have to take the path of this file to access the contents of this file, this CSV file. Here you can see that this is the file we have to read. And how we can read is using pandas. So what we will do? So data frame is there. In pandas, there is a data frame. Data frame is a window that can contain your data, that will contain your data. So you will consider it as a window like thing. Okay. Or you can consider it as a typical kind of an array that has some data in it. So I'll use df for data frame. So df equals to, because pandas we have imported and we have given an alias for as pd. So pd dot read. What kind of file is this? This is a CSV file. This is a CSV file. So read underscore CSV. Now we have to give the location of that file. So how you will do that? So it has to read a CSV file. And what is that CSV file? So that CSV file is located in my Google Drive, and I have to copy the path from here of this CSV file. This CSV file, there are three dots, options will be there. Click on that. You will see a copy path option. So please click on this copy path, then paste it inside single inverted comma. This.
Samir, sir?
Yeah.
Sorry for the interruption. So can you please increase the font size?
Okay.
Thank you, sir.
So I think it is too much. Yeah. Is it now comfortable, Purnima?
Yes, sir.
Yeah.
Thank you, sir.
Yeah, thank you so much.
Or what you can do, Samir, you can reduce the size of this left pane. Yeah.
Yes, ma'am. Yes, ma'am. So I am closing this left pane because we have taken the path. Okay. So this is what we have done, and I ran that this cell. So these are the cells actually. So these are coding cells. You can add a text cell also. I'll tell you later. Okay. So pd.read CSV is inside the data frame. Okay. So have you done this thing? If you have done this from your side, then please write PD or CSV. You can write CSV, or you can yeah, you can, yeah, thank you so much. Write CSV if this CSV has been transferred to this DF data frame. Yeah, thank you so much. So I think many of you have done this thing. Good. So we'll proceed. Okay. Now we have this CSV file inside this data frame. So when you'll write DF, you'll see that, yeah, there is something inside this data frame. So here you can see that there are 247 rows and it is saying one column. I don't know. Okay. So this is actually yeah. So this was there in my file. Again, I have to check whether I've done correctly or not. So I'll come back to this folder, and the first row it is saying, okay, I have to save it first because I haven't saved it. So let me check once again. Yeah, this is there. Now I'll remove that file from here. Yeah, this is removed. Again, I will upload this file from here. Yeah. So it is uploaded, and then come back to this thing, and then again I am going to, okay, I have to refresh this Google Drive again because I have uploaded this file. So I have to refresh this file, this folder, Google Drive, and then I will click on this, and then I will check. Yeah. So now there are how many rows? 122 rows and 14 columns. This is correct. So how to get the path? Somebody asked me. So to get the path of the file at the left, okay, I'll tell you. This is the folder option that is given beside this this window notebook. Okay, so you have to click on this folder option. When you click on this folder option, you have to press this button, mount the Google Drive, because it is already mounted in at my end. So it is showing me option of unmounting the drive. So you have to mount the drive. There will be a Google Drive. So it will look like this. It will look like this. There is a drive option, sample data. Inside drive, you have to go to the my drive. You have to go to my drive, and then inside my drive, your folder that I've asked you to create at your end. And then there is a file, this Algerian forest fires data. Then you have to copy the path. Inside the single inverted comma, you have to paste that path, and then you have to run this cell. In the simple way, we can do that. Yeah. Thank you, Purnima, for answering certain questions. Yeah, assisting me. So Purnima is also my colleague. We both are working. So here, a data frame shows you, the attributes. Now we can see that in the year, under year column, okay, year is common for all the attributes. So will it be useful to describe a particular, whether there will be in a particular line there, whether there will be a fire or not fire? So is year useful or not useful? Can anybody tell me useful or not useful? You can write in the chat box. Useful or not useful? I'm asking you about year. Not useful. Yeah, very nice. Because the same value is in all the rows. So this is not this parameter will not help you in in finding out whether there will be fire or no fire. So for that you have to drop the year. Okay, so first thing is first operation is df dot keys. So from df dot keys you can find out what are the keys. Keys means the column value, this column values, like what are the names of these columns. So there's day, month, year, temperature, RH, WS, rain, FFMC, DMC. So these are all attributes. So df dot keys will tell you what are the attributes. Okay, now I have to drop the year. So what I will do, df equals to df dot drop, and inside this drop, inside this parenthesis, and then you have to write the square brackets. Okay, you have to press, you have to keep square brackets over here, and then you have to type year. So comma axis equal to 1. So you have to drop year. Now when you will again print these keys, you will see that year is not there. Year is not there. Thank you. Yeah, so can you please write in the chat year dropped? YD you can type year dropped. Okay, axis is actually axis 1 equal to is meant with column actually. 0 is for rows. Okay, so I think many of you have done this thing, year dropped. Now we will proceed. So we are having again a new data frame that is not having year. Okay, now let us go further. When you will observe these attributes, you can see that in front of RH there is a space here. In front of WS there is a space. After rain there is a space. Okay, then you'll see after classes there is a space. Okay, so whenever there is a space, and when you will write like suppose df, inside df I will write it was showing me, so I am writing classes. It is saying that key error, there is no key named as classes. Why? Because classes is having this space. Okay, so we have to again remove all these white spaces, so that while we are writing our code, there should not be any problem. So for removing these spaces, white spaces, you have to use a strip function, strip. So df dot columns, from the columns we have to remove the white space. So from df dot columns, there are 4 messages. Year was 3rd column. Yeah, so year was removed. Swati madam, we have removed year earlier because it was not having any kind of it was not useful, right? So df dot columns. Now from these columns, what we have to do, we have to remove the white spaces. So str, we have to use a string, and then strip. So this is the class and this is the function. So from string class we will be using strip function. Strip function automatically removes the white spaces. So when we will run this thing df, this is the code that we will be using to remove the white spaces. So remove white spaces from the column names. Okay, Now, again, when we will write df.keys, so there is no white space. Okay, so you can see over here. Okay, let me tell you one thing. This is 0, this is 1, this is 2, this is 3. So always indexing starts from 0. Okay, now let us see again our data. Okay, here you can see that there are classes that can be defined with the use of a label like what should be this class 0. So we will rename, like we will give a name, we will give a label to every class, since there are only two classes, fire or not fire. So we will name those as 0 or 1. So suppose we want to give not fire as 0, label as 0. So for not fire, the label will be 0, and for fire, the label will be 1. So how to do that? So first thing is that you have to again strip, because there are values, like suppose we will write set. Using set function, you can identify what are the unique values. So df dot in which attribute we have to see. So we have to see, sorry, not in temperature, in classes we have to see. So when you will see, it is saying there are 5 different labels. Why? Because in this fire and in this fire, there is only one space. Then there are more than one space. Here one space, more than one space. So here you have to refine this thing. Okay. So you have to pre-process, you have to again strip. Now, because this is, the stripping is to be done not on the columns, but on the values, like for on each row. Like for this row, not fire should be like this, and fire should be like this because there is some space. So for that, you have to strip on classes. So what you will do, df dot classes, you will use df dot classes equal to new classes. What will be the new class? So df dot classes will be equal to classes dot str dot strip. So this is the same function. Okay. And then okay, sorry. Now, when you will use this set df dot classes, so there will be only two classes, fire and not fire. So again, data frame is updated. Okay. So we have done two things. What we have done, str should, if a strip is not working, I think str, the s should be small. Strip, the s of strip should also be small. Classes, there should be capital C. So please check it out at your end. Let me. Okay. Now we'll proceed further. I think is recording being done?
Yes, sir. The session is live.
Session is live.
Okay, ma'am. Yes, ma'am. Yes, ma'am.
Session is live.
So now what we will do, we will start with, labeling these classes. Okay. So for that, we have stripped this thing. Now, one thing that I've already told about you about this thing, scikit-learn. So we have one new ththing, scikit or sklearn. and we have to use pre-processing. And one thing is that label encoder, this is what we need, label encoder, scikit-learn label encoder. So what it does, actually, it will go through this whole data frame and it will keep on recording that how many classes are there. So we can see that there are only two classes, fire and not fire. So now it will give a label 0 to fire, and whatever number of classes will be there further, it will keep on labeling them with the increment of 1. So 0 for this, 1 for this. Suppose there would have been like, suppose 10 classes. So it would have labeled them from 0 to 9. So 0, 1, 2, 3, 4, and all that, like that. So we have to use this sklearn pre-processing label encoder. So either you can copy this thing or I'll tell you how to do that. So first I'll copy this. Now write from sklearn.preprocessing import label encoder. So we have imported label encoder. First thing is this. So this library is now available in our notebook. Okay. Now we have to, because the label encoder is a class, we have to define an object for that. So label encoder equals to pre-processing. Okay, pre-processing, or yeah, from sklearn, you can use like from sklearn import pre-processing. So label encoder is equal to pre-processing dot label encoder. Okay. So label encoder is there. Yeah. Label encoder. There are two ways. I'm actually telling you in the easiest way, like, because pre-processing we will be using further in this notebook. So that is why because when I was doing like this, Control Z. So only label encoder was actually imported in our notebook. I need more than that, like not only label encoder, but all other pre-processing functions. So I'm using like from sklearn import pre-processing. Okay. And using this pre-processing dot label encoder, we'll do further operations. Now, there is a method that most of the pre-processing functions use is fit transform. So how you can do that? So df is the data frame. In df, you have to use classes, and these classes has to be encoded. This class, because there are two classes, fire and not fire, so these classes are needed to be encoded. So what I'll do, label encoder, this label encoder we will be using, this label encoder, this object. So label encoder, and we'll use fit transform method. So it will fit on that and then transform. So what is fit? Fit means it will identify this is 0 and this is 1. Transform is what? It will replace this fire from 0 and then not fire from 1. So there are two things. Fit is what? It will identify, it will not convert that. But when we will use transform, then it will convert that. So this method can be used in two different lines. First is fit and then transform. And if you want to use both of them in a same line, then you can use fit transform. And then again, what is the thing we need? So df classes, we need df classes. This is the thing. This is what we needed. So name pre-processing is not defined from sklearn. Yeah, and then this. Okay. So now when we will write this, like df, or you can add df.head. Head, I have told you. Head means the first 5 lines of this. So first 5 lines from 0 to 4. The classes, early classes were 1 actually. Okay. So, and if you want to see have had this encoded or not. So yeah, this function has encoded all these classes as either 0 or 1. Now, so we will proceed further. Now, because we have prepared our data set right now, so it is, I think it is prepared. Okay. Now we know that, like, this is the file. Okay. So let's have some view on this thing. So these are considered as features. These are considered as features. So I'll, color them with some green color. So these are features. And this is actually the label. So this is label. This is label. Now because this whole, all the contents are in a single data frame. All the contents are in the single data frame. So how to, separate them? So actually this is from 0 to n minus 1. Suppose there are n features. So this is from 0 to n minus 1. And this is nth column. This is nth one. So how to do that? So when we are using this, we can write y, like there are two things. X is, like, I'll comment this thing. X is or will be referred as features, and y will be the label. Okay. So for each row, there is a label. So how to separate these two things? Okay. Since it is not a code, so no need to run that thing, but let us do that. Okay. Now, X equal to this, we know that it is, we have to take that content from df. So df dot, there's one thing, location lock. So df dot lock, make a square bracket, and in this lock we have to use all the keys. So for all the rows, we need all the rows, but how many columns? n minus 1 columns. So all rows, comma, all columns minus 1. But columns is not referred because it is not an array. So we have to write keys from 0 to minus 1. Square bracket we needed from 0 to minus 1. And then again a square bracket. So df dot log, all rows with key values from 0 to n minus 1. So minus 1 means except the last one, except the last one, except this one, except the last one. So let us do that and see. Oh, so it is saying it is not. Name keys is not defined. So let us define the keys. So keys equal to df dot keys. Let us do that again. Yeah. So now X is the feature vector. Now from here, X is the feature vector. So how I will write this in the text button. I'm pressing this. From here, X is the feature vector. So from here, X is the feature vector. Same thing we have to do with the label. So what will be the label? So label is y, small y, that is already I have defined. And what about the key? So all rows and the last key. So for last key, you can write directly -1. So from here, I'll make a new text. Again, hash is for larger context. And then here, y, small y is the label vector. So we have x and y. Let us write this df, sorry, x, oh, capital X here. So x is the label vector and y is the, sorry, x is the feature vector and y is the label vector. So here you can see y has only one column and x has 12 columns. Now we will proceed further. So can you please write in the chat line number 23, way back. Yeah. So this is line number 23. And please tell me whether you have done XY. So you can type XY in the chat. If you are with me right now, please write XY in the chat. Good. Yeah. So we are here right now. So what we have done? So I'm again telling what we have done from the first line. So we have taken a data frame, pandas. We have taken pandas, NumPy, and then matplotlib, and then we have read the CSV file. Then we have taken that CSV file into a data frame, and then we have pre-processed this data frame by removing the year because it was consistent, it was not changing. Then what we have done, we have stripped with the string, with the white spaces on columns. Same was applied to the classes. Then we have encoded these classes with 0 or 1. Then we have, because we have to train the classifier, so we have two data frames right now. First data frame is X, which is a feature vector. Y is the second data frame, that is a label vector. Now, since the classifiers that are given in the library of sklearn, these classifiers will not take data frame to learn. They need an array. So here that there comes NumPy. NumPy will be used to convert these data frames to an array. So let's do that. So what we will do, since X is a data frame, we will convert directly into a NumPy array. Some call them NumPy. I'm using NumPy Python. So X equal to again np dot array, and then I'm again sending X. Same is with Y. So Y equals to np dot array Y. Please do this thing, these two operations. So we have converted data frames into a NumPy array. So we have converted data frames into arrays. So now X is, so we can use like X dot shape. So what is the shape of X? It has 122 rows and 12 columns. Now we will write Y dot shape. So Y has 122 rows and only one column. That is why there is only one comma, no other column. So there are only 122 rows. Yes, so this Y has only 122 rows. So I'm removing this and I'm pasting it over here. So there are two things. It has 122 rows. This is Y and this is X. So this is X. And one more thing. This is X. And this is Y. this is X, this is Y. One more thing, when you have converted this data frame, X was a data frame, you have converted it to a NumPy array. Now the attribute was actually they have gone. So we don't have any keys right now. So here there is X. Okay. And somebody have Chetram ji, aapka Mr. Chetram, your let it be. So there is one X. Now inside X there are no keys because X has been converted into a NumPy array. So when you will write like X0, the first row of X. So there are no keys. Okay. So there are only values. And when you will write Y0, so first row we are checking. So there will be only one value, that is 1. Great. Let's move further. Now, suppose we have to, the pictures are very, they pull your mind and they pull your attention. So let's plot some graph over here. Then we will train the classifier. So let's plot a graph. So we'll use matplotlib. That is already, imported earlier, this matplotlib library. So matplotlib.pyplot as PLT. So we will be using pyplot. Okay. So we'll find the percentage. So percentage equals to df dot, okay, we have converted that into an array X and Y, but data frame is always there because we have not dropped that data frame. So df dot classes and then dot, because I have to make you to use this data frame easily. So don't hesitate, because we have already used arrays in earlier languages like C and C++. So we are very comfortable with arrays, but not with data frames. But data frames are very good thing. So let us use data frames. So percentage equals to df.classes.value counts. Value counts is the function that we wanted to use actually. And then we have to normalize that. So normalize equals to true. It should be true, like, yeah. So true into 100. So this is what we have, because we have normalized the data and then we have multiplied it with 100. So percentage we have got. Okay. So when we will use percentage, this is what we have computed. So when you will find percentage, so it will tell you how much percentage of, entries or how much percentage of rows are for particular data set, like for data set for particular label. So for label 1, there are 51% images, and for label 0, there are 48% data. Sorry, no, I'm very sorry, I've said images. It is not images. So 51% data is related to what label? The first label, that is not fire, and the second label is 0, that is fire. So 48% samples are from fire and 51% samples are not fire. So there is no imbalance. I think there is no imbalance. We cannot say that it is a class imbalanced problem. So it is balanced. So it would have been like 70-30%. So it would be an imbalanced class. Now let us plot the pie chart. So I'm writing it like very fast because time is not there too much. So I'll write them fire, and the second one will be not fire. Okay, and then we'll plot the figure. So plt dot figure. This you have to, there is no logic behind it. So please, you have to practice it. So fixed size. It should be like, let us take it 1610. I think 1610 will be good. So 1610. And then now we will be using plt.pie chart, because we are telling you that how much span is for a particular class. So percentage. Now labels equal to class labels. And we have to give the title. So it is not always required, but yes, let us give the title also. So this may be helpful for you while writing the research paper when you are computing some things. So you have to paste your, outcomes in your research paper. So pie chart of labels. And again, font size, we will give it as 16. Now plt dot show. Let us do that. So we have done fire not fire, plt dot figure size. Okay, plt dot py is this class labels. Good. Okay. So let us plot this thing. So class labels is not defined. So classes, actually, this is classes. So this is the pie chart it is giving us. Yeah, so we can see that. And I think auto, there was one thing, auto PCT. Yeah, this is, we'll define it like percentage 1.1 float we have to define. Okay. So float and 2 decimal places. So let us see. Yeah, so it is giving you percentage 51.6% and 48.4%. So this is what we have plotted right now. So I think it is not compulsory to plot this figure. So you'll be getting, I'll share this file with you. So don't write this thing. This is just for sake of, you can use the plotting matplotlib. Now there comes, now we will start training from here. So training the classifier, that is, in this session, we will take it as SVM classifier, support vector machine classifier. Yes. Now training the classifier. So we have X and we have Y. So there are 2 things only that is needed by the classifier. Okay. Now, so what is the classifier that we are going to use is, you have to again go to sklearn. So sklearn and then SVM. So there are 2 things with SVM. The first one is SV support vector classifier. Okay, and SVR support vector regressor. Okay, so SVR and SVC, there are 2 things that are given by the sklearn library. So in this SVM, there are 2 things. So there's a regressor and there is a classifier. So C is for classifier, R is for regressor. You can see here. So yeah, so let us go there. So we have to import this sklearn SVM SVC. So let us copy this thing and then here. So from sklearn dot SVM import SVC. So I'm asking this notebook to take SVM from SVM the SVC. Okay. Now next thing, this data, actually this complete data is needed to be splitted into 2 categories, like 2 parts. First one is that we have to take some data for this training, and then the part of the data we will be using for testing. For that we have to use train test split. So train test split is a function that is given by sklearn again. So sklearn dot pre-processing, sorry, model selection is there. So sklearn dot model selection, and there is train test split. This is the function that takes the data in the form of X and Y and splits this data, whatever you will give you, like how much, what is the percentage of splitting. So let us do that. So I'll tell you. So we will be using train test split. So this is the thing. Why I'm copying this, I know, but why I'm copying this, so that make you comfortable. Like you can also do these things. This is not very hard. So from sklearn dot model selection import test train split. So we have done one more thing. Now, how to split the data into training and testing. So first we will decide. There'll be a train, so X train. So X will be divided into X train, then X test, then Y train, and then Y test. This you will get it from here. Model selection. So it will give you return you the things like X train, X test, Y train, and Y test. Okay. So yes, you can use directly this. So let us do this thing. Yeah. So equals to test train split. So we have capital X, that is for features, and small y for labels, and test size is 0.33. So we are dividing it for 33%. We are giving it to test. So you can also use 30%. So 0.3 is 30%. Random state is randomly it will divide. So that suppose your data is actually the first 100 rows are for label 0 and the next 100 rows are for label 1. So if we will divide, we will not use random division. So it will take the data set that is biased towards a single class. So for that we are using this. Now let us see. Yeah, so there is an X train data set and then Y train. Okay. Now we will use this support vector machine that will use this X train and X test, and then X train and then Y train, and then it will be trained on that. So let us write SVM classifier, sorry, SVC, directly we can write SVC equals to capital SVC, and then we are defining. So this SVC is defined with, we have to define kernel, what kind of kernel we are using, what is the degree of that kernel, and all these things. So there are certain parameters that we have to, check, and then we have to initialize. So let us start with kernel. So kernel, the easiest is a linear kernel. So linear, and we don't need degree and nothing. So whatever default values it is taking, it will be taking. Okay. So this is what we have defined, SVC. Now we will use this SVC. So now this is the support vector machine that we have made, and we have told that I want a linear kernel. Yes, ma'am.
Can I interrupt you?
Yes, ma'am.
I hope Purnima is answering those questions, because some questions are popping up. I hope somebody is taking care of that.
Yes, ma'am.
Purnima?
Purnima is there.
Yes, ma'am.
Purnima is there.
She's there, but she's answering or not, we are not very sure.
I'm answering.
Okay, fine. Thank you.
Okay, thank you.
Yeah, please go ahead.
Yeah, ma'am. So we will be using this SVC. Now, as I've already told you that in sklearn library, we use fit function. So svc.fit. Now we want to fit
Purnima,
this.
when you are replying to their comments, reply it on everyone, so that everybody knows if somebody is writing a question, what is the answer.
Yeah, this is what my concern
Okay, ma'am.
was.
Currently, I'm replying with personal chat.
Yeah. Reply it on everyone. Yeah, because question is on everyone.
Okay, ma'am. Thank you.
So we will fit this classifier with X train and Y train. So Y are the labels and X is the data. So SVC is now fitted with this training data. And now we have to check whether it is performing well or not. So to check, we have already taken out some part of data that is what is known as the test data. So here the test data is X test. So using this test data, we can check whether our SVM has been trained, but that is giving us good results or not. So what we will do, predictions equal to SVM. This is SVC. SVC dot predict. And what it has to predict? So it has to predict X test, X underscore test. Or make it Y pred. Actually, I'll tell you. Otherwise, there will be confusion. Now, so what we have done, just look at this thing. Okay. So what we have done, we have separated this data. Suppose this much data we have separated. Okay. So we have trained the machine with these features and these labels. Now we are using this data to predict something. So suppose it has predicted something. So suppose because I'm not able to write right now, it will take some time. So suppose it has predicted this thing. So this is prediction. These are predictions. So we will term it as ypred. And these are actual values. So y underscore test. So by actually analyzing these two things, we can identify what is the accuracy. We can calculate the accuracy of this model. So for that, we have ypred and ytest. So ytest we know we are already having. So actual labels are there. So for this X test, we are having actual labels as ytest, and these are the predicted labels. Okay. So now we will do some. We will calculate accuracy or some scores. So what for that we have to import from sklearn dot matrix import accuracy score. So we have to import accuracy score, and then this accuracy score will be calculated based on ytest and ypredict values. So what has been predicted and what is the actual? So these are ytest is the actual label. So ytest is the actual label and ypred is the label predicted by the trained classifier here. So let us compute. So it is saying that accuracy is 91.89%. So we have trained a support vector machine with linear kernel. Linear kernel means the plane, the hyperplane with that we are having, like, is linear. Now we can have different kernels also. So I think you have trained this with me. So you can type done. You can type in the chat whether you have done completed training or not. So trained, you can type trained in the 92.68. Good. What about other people? 91.89. Yeah. So here you can also change the kernel. Like suppose I am changing the kernel, and we'll go back to this SVM. And now in place of linear kernel, I'm using polynomial. So let us go there, and I'm typing poly. Now we have to define the degree. Here you can see So whenever we have to define, so degree we have to, when we are using polynomial kernels, then we have to define the degree. So degree equals to 3, or 2 is the quadratic sort of kernel. So initially the accuracy score was this for linear. Okay. Now let us check it for, this is for poly, with degree equals to 3. So with degree equal to 3, it is lowering down. Let us, sorry, degree equals to 2, I think. What degree I have taken? 2. Let us make it 3. $89.18. Okay. So it has improved from 2 to 3, and then you can have different degrees. You can also take RBF, radial basis function also, that kernel also, that kind of kernel also. One more thing that is left behind is the data is not normalized right now. So we can normalize the data by using some standard scalar that is given by sklearn. So we'll use sklearn for pre-processing our data. Normalization means, because this value is integer, so it is giving you temperature is in the form of integer, and then rain is integer. These values are having different, this particular measure is having a different value, this DC is having different, so they are having different ranges. So we can normalize this data using standard scalar. So let us use a standard scalar, and then let us check whether there is a possibility of improvement or not. So this can be done while you are doing your research problem. You are suggesting some solutions to a research problem. So let us do that. So from sklearn dot pre-processing, import standard scalar. So this is the standard scalar that we will be using. Now, using this standard scalar, we can change the features. So how we can change? So x train scaled, comma, x test scaled, because these features need to be scaled, not these labels. So we are not using y here. So x test scaled and x train scaled equals to, now what we will do is yes, first we have to define the scalar. Yeah, so we have to define the scalar first. So scalar, again, this is the object. So from standard scalar, we are creating this object, then scalar dot fit. So we'll be using as x train scale is equal to scalar dot fit transform. Okay, x train, and then x test scaled is what? Scalar dot fit transform x test. So let us do that. And okay, now we have two new features. So from x, this capital X, we have scaled this x and transformed this x to x train to x train scaled, and same is for x test. Okay, now where we have trained this SVC, so let us train this SVC with new features. So x train scaled, yes, Okay, now it is trained. Now predicting. Again, now we will see that what is the, for degree 3, we have achieved 83.78. Sorry, 89 for degree 3. So let us see if is there any change. So for this degree 3 is 89. Okay. So yeah, so we'll do that. So you can see over here, by scaling, it is not performing well by scaling this. So there are many problems where this scaling works, and there are some problems where scaling doesn't work. So and let us test for other like we should take it like linear kernel. So linear degree doesn't matter for linear. So linear kernel, it is 89.18. That was 92 in our case, 91 or 92, I thought. I don't know. I don't remember. Yeah. So this is what we have done in case of classification. Okay.
We have
can
5 minutes. Yeah, Samir. We have 5 minutes now.
Yes, ma'am. So this is the classification that we have done. In this case, I'll share with you the same thing, say on the same data set, a regression problem. So what is the regression problem? Suppose this is the data. Just leave this thing. I'll make a copy. Okay. Okay. So suppose we don't have to do classification. So I'm removing this class label. Now we are having these features. Now suppose I have these much values, these values, and then I have to predict what is the temperature. So I have to train the classifier that has temperature as the label. So we will make it as label, temperature as label. Okay. And then we will train this classifier on these values. So see, what is the difference between regression and classification is that regression can have as many values, like the temperature can have a good range, but classification has only, a small number of classes. Like if you are having thousands of samples and then you are having only 10 classes or 20 classes. But in regression sort of problems, there can be a different value, like what should be the predicted values. So in this case, we have to use not SVM classifier, not the SVM classifier, but the SVM regressor. So let me tell you, because time is not giving me permission to explain you more, but I'm having a notebook right now. So let us open that notebook. Yeah. So regression. So I'll take another 3 minutes and then you'll come to, it will be very easy to, because we have done the similar kind of thing. So this is the notebook, similar kind of notebook. So in this notebook, as compared to this one that we have done right now, so we have the same data set, but we have removed the classes. So we have dropped the classes here. So here we have dropped. So here we have earlier also here we have dropped. But in this case, Y is the label that has temperature, and X does not have any feature that is related to the label that is fire or not fire. Okay. And again, the same X and Y. So this X contains here, in this file, X was containing what? All these things, day, month, temperature, and all that. Here, we have only taken these fields, and temperature as the prediction, like we need the prediction for the temperature. So these are the things that temperature has, and then there are unique values of temperatures, like the temperature is ranging from 22 to 37. Now we have used the same test train split, same standard scalar and all that. And here we have used SVR, support vector regressor. Instead of classifier, here there was a classifier actually we have used. So that you already know. So we have used classifier here. Now here in this notebook, we have used SVM regressor. So we will use SVR, and then we have predicted. So for prediction, here prediction is not, if you have to compare the prediction, so prediction never be like, suppose the temperature is 23, so prediction can be 22.5 and 22.8 also. It can never be 23, or it can be 23.1 also. So the accuracy is not the correct measure to measure the performance of these regressors, especially. So what we will do, we have plotted a graph. So here you can see that this is test data set. The blue line tells you about the test data set, and the orange line will tell you the regressor actually. So this regressor, you can see that it is sometimes very close to the actual labels, like actual values of temperature. It is very close. So these peaks, you can see that, yeah, it is very close. Since the data set is very small, so the prediction can, there may be a possibility that prediction is not very good, but it is still doing some prediction. So here we have computed the score actually. So score here, this is what we have to go there. Score is not actually the accuracy. So when you'll come to this thing, there will be a score that is defined as a coefficient of determination. The coefficient of determination is there. So you will read the SVM library will give you the formula for that. But mean square error and mean absolute error are there that should be computed, so that we will come to know that this should be minimal. So here the data is not like that. It will give you a correct means our SVM classifier is not fitting because the data is very small. But when you will apply a regressor on your problem, which is having a good amount of data, then the mean square error should be less than 1 or less than 0.5, and then this mean absolute error. So absolute is nothing but original, like y predict, y test minus y predict, and then you have to add it and average it and then add it. And then mean square error is compute the difference and then make it square and then add it. So these are the metrics that we can use. So I'll share this file in the same directory where we have pasted our data set. We have uploaded our data set. So don't worry about this. And this is 7:31 now. So thank you very much for listening me. I think you must have got something that will help you in your research purpose. Thank you so much, ma'am. Thank you. Thank you, everyone.
Brilliant session. That is what somebody has written. Thank you. Wonderful session. Great session. Amazing session. You are getting so many compliments. That shows that the session was successful. And I'm always so glad and proud of my students who keep the sessions very live. I'm sure that in this short span of time, Samir was able to justify the topic. Of course, he could not complete the regression part, but my suggestion to all of you will be that please go through the notebook that we will share with you, and all the participants who are regularly attending will be getting the link. Don't worry about it. So it generally, videos are very large in volume, so we have to compress and then upload, and that takes some time. So don't worry, we will be sharing with you all the video links. Number one, all the Python notebooks that our experts will be using to explain to you the sessions. So nothing to worry about it. Everything will be shared with you except the PPT, because we are in the stage of writing e-content. And once the e-contents are generated, that will happen by the end of June. So we will be sharing with you the this news also, that the e-content is available on our website. Thank you so very much, Samir, for your excellent session.
Thank you so much,
And
ma'am.
thank you, Purnima, for giving us the support by answering questions individually. And I'm sure that people here have got some good information, and they can carry on with their research with this, considering this as the basis. We will be meeting tomorrow. What is the time tomorrow? Let me check. I think it is tomorrow also 3:30, right? So we will be meeting 3:30, and my colleague Dr. Shravan Kumar Mohanty will be delivering a lecture on unsupervised learning, especially the clustering methods. With this, we thank you all, and please enjoy your time with your family and friends. Have a wonderful dinner, and we'll be meeting tomorrow.